Hello everybody. So in the previous video, we went through wedge friction, which was the second type, which comes under the friction part. Totally, you have four types. The first type is the general friction, which we went through already. We have completed wedge friction as well. And now we'll be going through the third type of friction, which is ladder friction, I hope you know what ladder is. Let us concentrate on ladder friction. Let us try to understand what ladder friction is. I hope you are aware what ladder is. So ladder is technically a device which is used to either climb up or down. So if a ladder is being kept under usage, it will always have two contact points. If I consider this as a cross section of a ladder, ladder will be in contact with two surfaces. One of the surfaces will be the vertical surface. Usually it will be a wall. And the other one will be the horizontal surface, and usually it will be floor. Ladder will always be in contact with two surfaces. One of the surfaces will be the vertical surface, and the other one will be the horizontal surface. Usually the vertical surface will be wall and the horizontal surface will be floor. A common concept is if a ladder is kept, or if it is leaning towards the wall, it will have two contact points. One will be with the wall and the other one will be with the floor. So let me mark the contact point of ladder with the wall as A and contact point of ladder with the floor as B. Two contact points A and B. So if the ladder slips down by any chance, if the ladder slips down, then point A will move vertically downwards. The trend of motion of ladder with respect to the vertical surface will be downwards, and trend of motion of the ladder with respect to horizontal surface will be horizontally to the right. Hope this concept is also clear. I'll just share and show the concept of ladder which slips down. Whenever a ladder slips down, the trend of motion of ladder with respect to the vertical surface will be vertically downwards, and trend of motion of the ladder with respect to the horizontal surface will be horizontal to the right. In this case, let me just show the shared screen. It goes in this way. If you can see the animation, this is the trend of motion, which is downwards, which falls downwards as far as vertical surface is concerned, and as far as the horizontal surface is concerned, it moves horizontal to the right. This is the trend of motion whenever a ladder slips down. So only when the ladder slips down, there is a friction between ladder and wall and ladder and floor. There's a friction which exists between ladder and wall and ladder and floor. So that particular friction is called as ladder friction. So we'll be studying the concept of ladder friction. Even when the ladder is staying stationary, there is a friction between ladder and wall and ladder and floor. Because of the friction, it stays. And when it moves, when it slips down, there is a friction. There is also another friction between ladder and vertical surface as well as ladder and the horizontal surface. So we'll be dealing with the ladder friction. This particular friction is called as ladder friction. Hope the concept of ladder friction is clear. So there are only two types of problems which may appear under ladder friction. So in one of the types, you will be finding the external force P. You'll be finding the external force P, which is to be applied at the foot of the ladder. So that the ladder doesn't slip down. A very simple concept. Whenever a particular ladder is being under use, you hold the ladder, you hold the foot of the ladder so that the ladder doesn't slip down. The same concept. You'll be finding the external force. You'll be finding this external force which is required to hold the ladder without slipping down, which avoids the slippage of ladder. So this is one of the types in which you'll be finding this external force P, which is used to hold the ladder without slipping down. And in the second type of problem, you'll not be having this external force. External force will not be given. So external force will not be given. So without the help of external force, you have to find that convenient angle theta, so that without the help of external force, ladder should stay stationary without slipping down. So these are the two cases. In the first case, you'll be applying an external force to the foot of the ladder so that so as to avoid the slippage of ladder. And in the second case, you don't apply the external force. We never apply the external force. Without the external force, you have to find this convenient angle theta. So that the ladder doesn't slip down. These are the two types of numericals, two types of problems which are available here. So let us try to understand the steps to solve. So either you'll be finding the external force P, which you applied the foot of the ladder in order to avoid the slippage of ladder, or you'll be finding the angle theta. You'll be finding this particular angle theta made by the ladder with respect to horizontal, so as to avoid the slippage of ladder without the help of it. These are the only two cases. In the first case, you'll be finding the value of P, and in the second case, you'll be finding the value of theta. So these are the only two unknowns which you'll be finding here, either P or theta. P is the external force which you apply at the foot, and theta is the angle made by ladder with respect to horizontal. These are the two forces. Two unknowns, which you'll be finding. Let us try to understand the steps which you follow in order to find these unknowns. Again, to understand the steps, I'll just consider an example of ladder which is in contact with the wall and floor. Let me consider this as the cross section of ladder. Now ladder is in contact with the wall, and let me consider the contact point of ladder with the wall as A and with floor as B. With wall as A and with floor as B. This is the wall and this is the floor. Now let me consider the length of ladder as L. Length will always be the inclined length. Length of ladder as L. Let me consider the length of ladder as L. Now, step number 1 is to mark the self-weight of ladder. Self-weight of ladder will always move vertically downwards. And self-weight of ladder acts exactly at the center of the span. If the entire span is L, then self-weight will be acting at a span of L by 2 from the top and L by 2 from the bottom. So once you mark the self-weight, this is A, this is B, let me mark this particular point as C, and let me extend this so that the line of action of self-weight meets the floor, and let me mark this point as D. We'll understand the significance of this particular process later when we solve the problem. So you have to mark the self-weight. Self-weight will move vertically downwards. And self-weight of the ladder will act exactly at the center of the span. If the span is L, the total span is L, self-weight will be acting at a distance of L by 2 from the top and L by 2 from the bottom, or it will act exactly at the center of the span. Now, so after marking the self-weight, if you have an external load given, even that has to be marked in step number 1. So external load as well, if it is given, it will be moving vertically downwards. External load L will also be moving vertically downwards. Let me mark this point as E. And once you mark the external load, you have to extend the line of action of external load so that it meets the flow. And let me mark this as F. And let me mark the last point as G. So step number 1 is done. In step number 1, you'll be marking the self-weight. Of the ladder, as well as you'll be marking the external force given in the question. So both self-weight and external force will move vertically downwards. Self-weight will act at a distance, act exactly at the center of the span. That is L by 2 from the top and L by 2 from the bottom. It will act exactly at the center and it will move vertically downwards. Once you mark self-weight, you have to extend the line of action of self-weight so that the line of action meets the ground. Similarly, you have to mark the external force as well, external load given. And even after marking the external load will also move vertically downwards. Even after marking the external load, you have to extend the line of action of external load so that it meets the flow. You have to mark all of these points where it meets. And let this be the last point, the corner point, and let it be marked as G. So this is step number 1, in which you'll mark self-weight and the external load. So in step number two, you'll mark the normal reaction offered by floor as well as wall on the ladder. Now, if ladder is in contact with the wall, so wall should offer normal reaction on ladder, is it not? Wall should offer normal reaction on ladder. Ladder is in contact with the floor, so even floor should offer normal reaction. Floor should offer normal reaction on the ladder. Whenever a body is in contact with the surface, surface offers normal reaction. Surface offers normal reaction. How should that normal reaction be marked? Normal reaction should always be perpendicular to the surface. Normal reaction should always be perpendicular to the surface, directed towards the body, and it should act exactly at the point of contact between the surface and the body, which is A here. Let me write this as normal reaction about A. Normal reaction about A. Similarly, now normal reaction, even the ladder is in contact with the floor as well. So normal reaction will be offered by floor. Again, normal reaction offered by the floor should be perpendicular to the floor, directed towards the body, and should act exactly at the point of contact between body and the surface, which is B. So let me mark this as normal reaction about B, NB. You can write it, you can indicate it in any ways. So I'll be writing it as NB and NB. So after marking the normal reaction, you have to mark the frictional resistance. Frictional resistance will always act in a direction opposite to the direction of motion of the body. Frictional resistance will always be acting in the direction opposite to the direction of motion of the body. You know the direction of motion of the body, is it not? This is how the ladder moves. If you observe, direction of motion with respect to wall is vertically downwards, and direction of motion with respect to floor is horizontally to the right. This is how the ladder moves. So direction of motion with respect to wall is vertically downwards. So if ladder moves vertically downwards, then frictional resistance should be acting in direction opposite to the direction of motion of the body. So here ladder moves vertically downwards, so frictional resistance will be acting vertically upwards. Let me write this as frictional resistance offered by wall. Which is equal to coefficient of friction mu into normal reaction NA offered by wall. Or if you get confused, you can mark this as normal reaction offered by wall itself, NW. FW is equal to mu into NW. Let me mark this as normal reaction offered by floor, NF. So friction resistance will be acting vertically upwards. Similarly, here, as far as this particular surface, floor is concerned, the trend of motion of ladder is horizontal to the right. If the ladder moves horizontal to the right, then friction resistance will be acting horizontally to the left. This is friction resistance offered by floor, which is equal to mu into NF. So you mark the friction resistance as well. This is step number 3. So after marking the friction resistance, you will not be drawing the free body diagram here. So free body diagram is a diagram where you bring all the forces to the center and you make it a concurrent force system, and then you apply the conditions of equilibrium. If you draw the free body diagram, then it's enough if you apply only 2 conditions of equilibrium, as we went through in the previous set of numericals. But here we'll not be drawing the free body diagram. Since you don't draw the free body diagram, the entire force system will be non-concurrent. If you draw the free body diagram, then the entire force system will be concurrent. Here, since you don't draw the free body diagram, the entire force system will be non-concurrent. Since the force system is non-concurrent, you have to apply the 3 conditions of equilibrium, not 2. You have to apply the 3 conditions of equilibrium. Which are the 3 conditions of equilibrium? Summation of Fx equal to 0, summation of Fy equal to 0, and the moment either about A or B should be equal to 0. A or B should be equal to 0. These are the 3 conditions of equilibrium which you'll be applying. Got it? So why 3 conditions? Because you don't draw the free body diagram. If you draw the free body diagram, then you bring all the forces to the center and you make it concurrent. If the force system is concurrent, it's enough if you apply 2 conditions of equilibrium. Only these 2 conditions. Summation of Fx equal to 0 and Fy equal to 0. Since you don't draw the free body diagram here in ladder friction, you have to apply the 3rd condition of equilibrium, because the entire system is non-concurrent. Since the system is non-concurrent, you have to apply the 3rd condition of equilibrium, which is moment produced by all of these forces either about A or B should be equal to 0. So this is the last step. By applying these three conditions of equilibrium, we will be finding the value of P and P or theta. P or theta. In the first type of numerical, it will be P, and in the other type, it will be theta. P is the external force what you apply at the foot of the ladder, and theta is the angle made by ladder with respect to horizontal. So either you apply an external force to avoid the slippage of ladder, or you find that convenient angle made by the ladder with respect to horizontal in order to avoid the slippage of ladder without the help of external force. Without the help of external force. Let me just repeat the steps. So step number 1 is to mark the self weight. Step number 1 is to mark the self weight. Self weight offered by self weight of the ladder along with the external force or external load. Let me mark it as L. Both will act vertically downwards. Once you mark self weight and external load L, you have to extend the line of action of both so that both the line of actions meet the ground or floor. Step number 2. Step number 2 is to mark the normal reaction offered by wall and floor. Step number 3 is to mark the frictional resistance offered by wall and floor. Frictional resistance offered by floor. Step number 4 is to apply the conditions of equilibrium. Step number 4 is to apply the conditions of equilibrium in order to find the condition of equilibrium, using which you'll be finding the value of P or theta. These are the steps. These are the steps to find the external force. What you apply at the foot of the ladder, or if there is no external force, you'll be finding theta. So using these four steps, hope this is clear. So we'll solve both the types in the next video. Till then, we'll meet in the next video. We'll go through the problems in the next video. Thank you.